Okay guys, so today I'll have a look quickly at the few questions, GCSE past paper questions on titration calculations. So we're going to talk through briefly first of all how to calculate concentration of a unknown solution. And then we're going to have an attempt at a few of those questions. So I'm assuming that we have done quite a bit of this in class already, and you're actually able to just sit down and calculate concentration using the equation where we have N equals C times V. Okay, where N, as you should know now, simply represents the number of moles of something. C is the concentration of it, and remember the units of concentration are different ones. The standard one is moles, number of moles that you have per decimeter cubed, in other words per litre, okay, or more importantly I suppose, because you very often work in cubic centimetres, a decimeter cubed is equivalent to cubic centimetres, 1000, and that's multiplied by volume. And very importantly here, the volume is in decimeters cubed. So the reason for that is so important is because if you get the volume in cubic centimeters, which you generally do, you need to convert that from cubic centimeters into decimeters cubed. And that's one of the most common mistakes we see, where people get 1000 times the answer because they forget to divide the cubic centimeters by 1000 to convert it into decimeters cubed. Okay, so first thing we're going to look at here is the table below. You may well have done this in class. If you haven't, it'll be good practice for you. It's very important. So students very often have difficulty in working out new numbers of moles and new concentration values whenever you're removing a certain volume from one beaker to another, or one volumetric flask to another. So what we're doing here is we have initial volume of a substance. So I'll do the first one. Okay, here we have an initial volume. Okay, so if we have a look here, what we're doing is first of all we have in this one 25 cubic centimeters, the initial volume of my solution, whatever it is, maybe an acid, maybe an alkali. So if we just sort of imagine this in a beaker here, and if we say within that beaker we have 25 cc's, cubic centimeters, of whatever it is, it has an original concentration of 0.2 moles per decimeter cubed. I'll just abbreviate that to capital M. Now, first thing we need to do is work out how many moles do we have in here. Well, let's have a look. Your calculation over here tells us that number of moles equals concentration multiplied by the volume. The volume is in decimeters cubed, but our concentration is 0.2 and our volume is 25 over 1000, or 0.025. So that gives us 5 times 10 to the minus 3 moles in here. So I'll try and squeeze it in here. 5 times 10 to the minus 3. Now, the volumetric flask. So what we've done here is we've taken this and we've put it into a volumetric flask, which is a very accurate piece of glassware for measuring usually volumes of about 100 cubic centimeters, or in this instance it is a 250 cubic centimeter volumetric flask. So we've taken our 25, we've put it into the flask, and we filled the flask up then. That's the implication of the flask that we've used. We filled the flask up then to 250 cubic centimeters. In other words, we've gone from 225 up to 250. Right. So how many moles will we have in the volumetric flask? Well, we will have exactly the same. We will have 5 times 10 to the minus 3 moles. Because by adding water, I do not add or take away moles. All I do is add water. So I'm making this thing a bit more dilute. Next question then. So in other words, let's just say I have in here molecules. If I draw the molecules in these little green X's, just say, because I don't have much room, we have 2 molecules, and we put that across to there. Well, we still have 2 molecules, or 2 moles. We don't have any more, we don't have any less. Whatever was in here migrates to the volumetric flask. So let's have a look at the concentration now. Well, we've gone from 25 up to 250, so we've diluted by a factor of 10. So the concentration is now 5 times 10, concentration is now gone from 0.2 to 0.02 because we've diluted tenfold, and we can calculate that out if we want to by using this equation here, where C N equals C times V. So therefore C, our concentration, is going to be number of moles, which is, we've just established as 5 times 10 to the minus 3, divided by our new volume, which is now 250 cubic centimeters, or in other words 250 divided by 1000, which is that. So divided by 0.25 gives us the answer of 0.02. So you can either work it out just by saying, okay, that's been diluted tenfold, so it goes from 0.2 to 0.02, or you can use the C equals N over V calculation. That's purely up to you. Okay, right, now what we do, and I'll just tidy this up a little bit. So what we're going to do now is we're going to pipette out of this flask, okay, and we're going to pipette into, to do the titration, okay, which is into a conical flask. And what we extract out of this, I'm not going to try and draw a pipette because my artwork is not up to it on this piece of apparatus. Okay, so we're going to pipette, and I've said here we pipette out of this 25 cubic centimeters. Okay, so what we've got to do is calculate the new concentration in here and calculate the number of moles present in here. Well, let's have a look. If I have a concentration of 0.02 molarity in here, would the concentration be any different? All I'm doing is taking 25 cubic centimeters of that out and putting it into the conical flask. It's like having a glass of diluted orange juice and taking a mouthful out of it. Would the concentration of the orange juice in the glass be any different than the concentration of the orange juice in your mouth? Well, no, it wouldn't. So therefore the concentration here is still 0.02. Now, let's have a look then about the moles. So here at the minute we have 5 times 10 to the minus 3 moles. Would I have the same number of moles present in the conical flask? Well, if I take a tenth of the volume out of this volumetric flask, I will with it take a tenth of the moles. If you imagine there were 10 green X's in here, if I only take a tenth of this volume out of this flask, I will only take one of the green X's, a tenth of them. So therefore the moles in here, okay, is going to be 5 times 10 to the minus 4. I'm only going to take a tenth of the moles with me. Okay, so hopefully that makes sense. What we have here, guys, is essentially, first of all, is a thing called a dilution. Okay, and after we carry out the dilution, then what we do is we carry out an extraction. In other words, we actually take just a certain quantity out of it. Happens to be a tenth in this instance. So you have dilutions and you have extractions. Okay, so what I want you to do now is have a go at the other remaining ones in here. We've got 4 for you to do. Pause the video, have a go at them, and what I'll do is I'll put the answers up so whenever you hit play again you can access the answers. Okay guys, so there's the answers. Okay, so check those off, make sure you got everything right. If you're not understanding something or there's something wrong, please come and see me. Okay, so what we're going to do now is we're going to have a go at a few actual